Hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. We are going to do a couple integrals here. I Googled, or not Googled, I guess I YouTube Googled. I searched under YouTube, integral of, and the top 5 things that came up are what we're going to work on. So I figured we would just work on some of the most popular integrals that people want to know about here. And hopefully one of these will help you out as well. I realize now that for secant, I was going to use black for that one, but I prefer to use a black screen. Not really sure why, just something I do. So instead, I think we'll use white for that one. I kind of tried to theme all the colors a little bit. Like secant, I was going to use black because it's like, oh, like secant, like when you can't see, like everything's black. I don't know. So I was going to go with that, but we're going to go with white instead, which makes way less sense because it's the opposite. But anyways, Linux, the thing for that is like a penguin, which is like black and white, but also it's orange. It has like orange feet. So I was going to use orange for that. Secant cubed, when you look at Q, like the number 3 represents tertiary colors. Tertiary colors would be like when you mix a secondary with a primary or whatever. So I went with like a light green, like a yellowish green. Sine 2x, so a secondary color, so purple, because like green and orange are the other 2 secondaries. So I wanted to choose something that would contrast that. And then E. I don't know why I choose blue for E. Oh, Internet Explorer. Internet Explorer is blue, so I chose blue for that one. So they're all kind of themed. I did put a little bit of thought into this, but probably didn't need to put that much thought into it. So let's go ahead and jump in before I go on another tangent here. The integral of secant. So this one I would actually probably recommend memorizing because the integral for this is probably the most terrible on the list. In order to get this one, what we would have to do is we'd have to times it by secant plus tangent on the top and on the bottom. And that's the fastest way to do it. But also it's not very intuitive, meaning like, who's going to think to do that, right? So the reason why this works so well is because if I distribute that, then it would be secant squared x plus secant x tangent x over secant x plus tangent x dx. Then what I can do is I can do my u sub. So I'm going to do that. Let's see, over here maybe. No, let's squeeze it in. So if u is equal to secant x plus tangent x, then du would equal the derivative of that, which would be the derivative of secant is secant tangent plus the derivative of tangent would be secant squared. And that works out perfectly because that's exactly what the numerator is. Look at that. So that it actually, like this whole timesing by secant plus tangent thing on the top and on the bottom works out super well, but it's so not intuitive. It's so not something that you would think to do. So that u sub works out perfectly, actually. That ends up equaling, because then this would be dx, right? So then that is literally all of this. All of this right here is du. So it ends up just being du over u. That's the integral of 1 over u, which is ln u, ln absolute value of u to be exact, plus a constant, but then that would turn into the ln of the absolute value of u, the initial u sub, which was secant x plus tangent x, and then plus a constant. So that is the answer to the first one, and we can go ahead and cross that off the list now. Because it's on a white background, I'm gonna have to cross it off in black, but I'll try to cross the other ones off in the color that I'm doing them in. Oh, you know what? I already have orange set up. I didn't need to do that. Right, well, let's just go to purple, and then we'll do this. Okay. So there's the first one, and that one is probably the hardest one. The other ones hopefully won't take nearly as long to do. I would probably recommend memorizing this one. I have this one memorized because it's just easier, and the integral of secant comes up pretty often, so I would probably recommend memorizing it. The way I have this one memorized is that the derivative of secant is secant tangent, And the integral is actually kind of similar to that. Instead of secant times tangent, it's secant plus tangent inside of an ln. So it's the ln of something that looks like the derivative of secant anyways. So if you have the derivative of secant memorized, then you would just kind of like tweak it a little, and then you have the integral, so to speak. Okay, integral of the ln of x. This one shouldn't be as bad. We will say, I'm going to squeeze this because we're going to have to do all 5 of these. So I'm going to try to squeeze this in over here. So ln of x dx. For this one, we're going to need integration by parts, uv minus v du. So u would be equal to ln of x. Du then would be 1 over x dx. And then dx would just equal dv. So x would equal v. And then it's ultraviolet voodoo, uv minus v du. U v minus integral v du. So then that's just the integral of 1 with respect to x, which would just be x. So this is just going to be x ln x minus x. That one's actually not too bad. X ln x minus x. And it wouldn't be the absolute value because we didn't get the ln of x by taking the integral and resulting in it. So you wouldn't need to put an absolute value on that x there. All right, so that's it for that one. Next up is green. So the secant cubed of x. This one is kind of like secant. It's a little bit annoying. Probably not as annoying though. So let's go ahead and take a look. Secant cubed of x dx. So we're going to split this up. Secant x and secant squared of x dx. And then when we split this up, we can actually do integration by parts again. So ultraviolet voodoo, right? So uv minus v du. U would actually be secant. Du then would be secant tangent. U and then v. So we're going to choose dv to be secant squared x dx because it has a nice integral. The derivative of tangent is secant squared. So it makes for a nice integral there. So then we split it up. So it's going to be ultraviolet voodoo. It's going to be u v minus v du secant x tangent x dx. Okay, so we're just going to focus on this part right here for a second. So that's going to be negative integral tan squared secant. I'm kind of doing a little bit of scratch work here. So this is not like official stuff here. Tangent squared is secant squared minus 1. So then that would be secant cubed minus secant. But remember, it's the opposite of that. So then that would just be secant minus secant cubed. And remember, the secant cubed is what we're trying to find. So that is literally A. It's the answer A. I don't know if you guys can see that. It kind of got cut off a little bit because I'm getting towards the bottom of the screen here. I really don't think I'm going to be able to fit all of these. Whoops. But I'll scroll down a little bit as we go, I guess. Okay, so all of that would be equal to A. So then if I clean all that up, it would be secant x tangent x. And then remember, we cleaned all of that up and we basically said that it was going to be plus... and then it's the integral, right? So integral, 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 integral. So this is going to be plus the integral of secant x dx minus the integral of secant cubed of x dx, which is what we're trying to find in the first place. So it's literally the answer we are seeking. Okay. Now I'm going to cheat a little bit because we've already proved what the integral of secant x is earlier, so we can go ahead and just put that one in. So that's going to be ln of secant plus tangent. And that's going to be equal to 2a, which means that the answer is just going to be half of that. Right? So I am going to actually have to scroll down. Maybe I'll scroll out, or I'll zoom out so you can see everything once we get it all put in there. So maybe I'll kind of like go right and then go back up or something. I don't know. We'll figure it out. So so then we would just divide everything by 2. So then the answer is going to be 1/2 secant x tangent x plus 1/2 times the ln of the absolute value of secant x plus tangent x. Don't forget to put a constant. Gotta have that plus c in there. Okay, yeah, we are gonna scroll out a little bit. So what would this look like if I scroll out? Like, where do I end up with more space at? Looks like I end up with more space over here. And a pocket of extra space where my face was. I think we'll probably put the ln of e in there. So I'm going to go ahead and do that one now because this one is going to be the easiest one. Remember, the derivative of e to the x is itself, right? So if I take the integral of e to the x dx, it's going to also be itself just plus a constant, right? So that one's pretty straightforward. And then we get to the sine squared. So this one also is just a little bit tedious unless you have the formulas memorized. I'm actually going to show you where the formula comes from. So it's going to take a little bit longer than what I would normally take to get the answer. But remember that for the cosine, and I might use a lighter shade of purple here because that purple's a little dark. Let's go with this color purple here. Okay. So remember that the cosine double angle formula is cosine squared minus sine squared. Some thetas in there. If we want, there's actually 2 versions of this that we can get. We can get a version of it where we use only cosine squareds and a version of it where we use only sine squareds. I'm going to do the version where we do only sine squareds, but I'll go ahead and tell you what the other version would be as well, because I do have these guys memorized, and I would probably recommend memorizing these as well. So cosine squared is equal to 1 minus sine squared. So then we would get this. Oh, forgot to put a squared on that. So then this is 1 minus 2 sine squared theta. And then we can go ahead and start solving. It looks like I'm going to maybe run out of space here. Let me see. Let's move this over. And let's move this. Okay, we'll see. So I'm starting to write over my stuff a little bit here. Cosine 2 theta. Minus 1. And everything divided by a negative 2 would equal sine squared theta. I just did 2 solving steps at once just so I could squeeze everything in there. So I subtracted 1 on both sides, and then I would divide both sides by negative 2, or times both sides by negative 1/2 is another way to think about that. So that means that sine squared would be negative 1 times negative 1/2 would be 1/2. Minus, is that cut off? That is cut off a little bit. All right, I am going to assume, I'm going to go down just a little bit here. There we go. Okay, I can fit that in there. Okay, so 1/2 minus 1/2 cosine 2 theta. Okay, the other version, by the way, which I told you I would tell you, is cosine squared of theta is equal to 1/2 minus 1/2, or sorry, 1/2 plus 1/2 cosine 2 theta. So the 2 formulas are actually really similar. Anytime you're dealing with only even powers of sine and cosine in an integral, and they're being times usually, then you would do something like this, where you would split them up using these formulas. So that's actually what I'm going to do. Sine squared of x is equal to, so I'm finding the integral of the sine squared of x dx. That is equal to 1/2 minus 1/2 cosine 2x. Right, so the only thing that's really different is I'm using x instead of theta. I like to factor out the 1/2. You don't have to do this part, but I like to factor it out because it makes the integral look nicer. So then it's just this. So then that's 1/2. And then the integral of 1 with respect to x would be x. And the integral of cosine is sine. And then I would just divide by the 2. This is what I like to call the inverse chain rule for integrals. There isn't actually an inverse chain rule for integrals, not for every function ever. But if the inside function is linear, then the u sub would just end up being, you would take the derivative of the u sub and it would just be the slope of the line, whatever the inside function is. The derivative of that would just be m, whatever the slope is, and then you would end up dividing that out. So we would just end up dividing by whatever the slope is if we were using a u sub. I'm just not using the u sub because it's faster to do it this way. So that would basically be it, and then I'll just distribute that 1/2 again there. So that's 1/2 x minus, oh, by the way, sine of 2x would be 2 sine cosine, 2 sine x cosine x. Sine, that's a double angle formula, right? So sine of 2x is equal to 2 sine cosine, and then the 2's would actually cancel. So that it would still be a half because I'm going to distribute a half. But it would just be a 1/2 x minus a 1/2 sine x cosine x plus a constant. Don't forget to add your constant in there. Phew. Okay, we did end up kind of fitting them all in, but I did have to zoom out a little bit. So, you know, it is what it is. I'm going to try to zoom out a little bit more here. So if you want a screen grab of all the answers, this is probably as good as it's going to get. Unfortunately, you're going to get my face in there, but you can always crop that out. So go ahead and grab this if you need. These are like the most requested integrals on YouTube. So I figured I would do all of them all at once. Hopefully this video has been helpful and informative and whatnot. Go check out the 5 math mistakes everyone makes and how to avoid them. It's a free PDF guide I made on my website, myersmathematics.com. And I'll catch you guys in the next video. Blessings, y'all.